current in a bridge controlled rectifier when load current is perfectly filtered. What does it mean that load current I naught does not have any ripples? Okay, because it is perfectly filtered, I naught does not have any ripples. Okay, now if you see the input current in a bridge control rectifier, actually if you are not filtered, it will be, the shape will be like this. Okay, now he is saying that this is perfectly filtered. Now what is this output waveform? You will get a square waveform. So option C is the correct answer.
Shown below, which having an input resistance of 1 kilo ohm and the gain of minus 30, the value of feedback resistance as well as the R1 R. See, we know that the gain is for that one is minus RF by R1. Here R in is nothing but an R1. Hence R in is nothing but R1, which is given in the question itself, that is 1 kilo ohm. So 30 is equals to minus RF by 1 kilo ohm. So RF is going to be 30 kilo ohm. So R1 is 1 kilo ohm. Hence option C is correct. Circuit shown below, the relationship between the reference current as well as the I1. So the circuit which is shown in the figure is nothing but a current mirror. So I reference is nothing but 2IB, because both having this current is nothing but this current, this is nothing but I1 itself. So I reference, this is I reference is equals to 2IB plus I1. So we have to express IB in terms of I1, because the equation should contain only I reference as well as the I1. So IB is nothing but I1 by beta. So I reference is nothing but 2I1 by beta plus I1. So if we take I1 as a common, 1 plus 2 by beta is the answer. So option B is correct. This is I1.
In this problem, it is given that A is a matrix 2 1 1 2, and also given that P inverse AP is nothing but diagonal matrix of lambda 1 comma lambda 2, where lambda 1 and lambda 2 are nothing but the eigenvalues. Now then we have to find this matrix P. Now in order to find this matrix P, first we have to find the eigenvalues. If I calculate the eigenvalues, if I find the eigenvalues of A, then the eigenvalues will be nothing but 1 and 3. And you know the method, find the characteristic equation and find the roots by which you can get the eigenvalues. Now eigenvalues are nothing but 1 and 3. Let 3 be the second eigenvalue. Now when I take eigenvalue as 1, we'll have the matrix as 1 1 1 1. That is nothing but x1 plus x2 will be 0, which can be also written as x1 is equals to minus x2. From this we can get the matrix as minus x2 and x2, so it will be minus 1 and 1. Similarly, if I take the eigenvalue as 3, then the matrix will be minus 1 1 1 minus 1. That is nothing but minus x1 plus x2 is equals to 0. That is x1 is equals to x2. We can write this as x2 and x2. So that is nothing but 1 and 1. Now P is a matrix with eigenvalues lambda 1 and lambda 2, and the vectors, we know already the vectors. So the required value, required matrix P will be minus 1 1 1 and 1, which is nothing but option C. In this problem, it is given that 5 letters were to be placed in envelopes for posting. Unfortunately, the letters were dropped down before they are put into envelopes, and we have to find the probability that at least one is in the correct envelope if we arrange them randomly. Now we have to find probability that at least one is correctly placed, which can be also written as 1 minus probability that no one is placed correctly. No one is placed correctly, let us say. Now, so 1 minus probability of, number of favorable cases here, let us look into this number of favorable cases. Now here, favorable cases is nothing but there are 5 envelopes and we have to place 5 letters such that no letter is in the correct place. So it is nothing but dearrangements. So we know the formula of dearrangements. Dearrangements of n things can be done in n factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus so on up to minus 1 power n by n factorial. This is what we do for dearrangements. Now here the value of n is nothing but 5 because we have 5 envelopes and 5 letters. So the number of favorable cases is nothing but 5 factorial into 1 minus 1 by 1 factorial plus 1 by 2 factorial minus 1 by 3 factorial plus 1 by 4 factorial minus 1 by 5 factorial. If I simplify, this value will be nothing but 11 by 30. Now it will be 11. Now the required probability is nothing but 1 minus favorable cases are 11. Favorable cases will be 44. If I simplify, this will be 44 by, and the total number of cases are nothing but 120, which is 5 factorial. If I simplify, it will be 19 by 30, which is nothing but option D. The given non-exact differential equation is y plus x cube y square into dy by dx is equals to 0. This can be written as y dx plus x cube y square dy is equals to 0. Now here m is nothing but y, n is nothing but x plus x cube y square. Now dou m by dou y is nothing but 1, dou n by dou x will be 1 plus 3 times of x square y square. Now dou n by dou x minus dou m by dou y, 1 by m, or if you take 1 by n, the value is not in terms of only x or only y. So it is not in any standard form. So the answer is none of this because we cannot find any integrating factor here.
Z of z is equals to alpha z inverse plus beta z power minus 3 is distortionless low pass filter, then the relationship between the alpha and beta is. Here for the distortionless, the filter phase must be a linear function of omega, that is z of e power j omega is nothing but alpha j omega plus eta e power minus j3 omega. If we take it as common, that is e power minus j2 omega alpha e power j omega plus beta e power minus j omega, means the angle of g e power j omega is nothing but minus 2 omega plus angle of alpha e power j omega beta e power minus j omega. This phase must be a constant or 0. The angle of this must be constant or 0. For that to happen, alpha equals to beta is also possible, alpha equals to minus beta is also possible. For these two possible combinations, the angle is going to be real, means that is 0, but this is the low pass filtering action, that is at omega equals to pi, magnitude of g of e power j omega equals to 0. That means 0 is equals to alpha plus beta, that is alpha equals to minus beta is the correct one. We have to choose alpha equals to minus, that is option B is correct.